All right, welcome aboard. Today we're going to be talking about how to invert a 2x2 matrix. We're going to break it down BRNY style right now. So let's take the general form. Matrix A sub 0 is equal to A, B, C, D. And we are looking for the inversion of matrix A0, so that's going to be A0 to the negative 1. There are 3 steps to solving this. Step 1 is to find the determinant of the original A0 matrix. The determinant of A0 is equal to A times D minus B times C, where the determinant of A0 matrix cannot be equal to 0. In a couple of steps, we're going to be putting the determinant as the denominator, and we can't have 0 as a denominator. So just make sure you check to make sure your determinant is not equal to 0. If your determinant is equal to 0, then that matrix is not invertible. Step 2, swaps and signs. A and D are going to switch places, and B and C are going to be multiplied by a negative scalar. So your original A, B, C, D is going to turn into D, negative B, negative C, A. So A and D switched places. B and C stayed where they were, but they got multiplied by a negative scalar. Then we're going to put it all together. 1 over the determinant of your original matrix. This is not the determinant of your swaps and signs matrix. This is 1 over the determinant of the original matrix times the swaps and signs matrix is going to be equal to your matrix A0 inverted. Let's take a look at an example. Matrix A is equal to the following inputs: 1, negative 3, 5, 4. So A is equal to 1, B is equal to negative 3, C is equal to 5, and D is equal to 4. Step 1 was to find the determinant, which was A times D minus B times C. A is 1, D is 4, so 1 times 4. B is negative 3, and C is 5, so minus negative 3 times 5. 1 times 4 is 4. Negative 3 times 5 is negative 15, but it's with another minus here, so it's going to be 4 plus 15. The determinant is equal to 19. 19 is not equal to 0, so we're good to go here. Next was swaps and signs. So we're going to take the A and the D value, and we're going to switch their locations, and then we are going to multiply our B and C values by a negative scalar. So 1 goes over here, 4 goes over here, boom and boom. And then we multiply this one by a negative, and then this one by a negative. So that negative 3 becomes positive, and the 5 becomes negative. Now we put it all together. 1 over the determinant of our original matrix times the signs and swaps matrix is equal to matrix A inverted. So 4 over 19, 3 over 19, negative 5 over 19, and 1 over 19. Let's do a quick MATLAB check to see that we're in the right ballpark here. Matrix A, original matrix A, 1, negative 3, 5, 4. 1, negative 3, 5, 4. Good to go. We'll just use some quick MATLAB commands here to make this easy on ourselves. We'll say we're looking for the determinant of A, which is equal to det of A. Determinant of A is 19. That's what we got in our calculation. We're good to go. And then let's just go ahead and check the inversion of matrix A, which is INV of A. If we run that, we're going to get decimal values from MATLAB, but we can go ahead and check real quick. We'll just do one quick check. Our first entry value was 4 over 19, and then 3 over 19 for row 1. So let's check it out. 4 divided by 19, 2105, good to go. And then we're looking for 3 divided by 19, 0, 1579. There it is. So our calculation is correct, and we've confirmed it with MATLAB using these commands. And that's how to invert a 2x2 matrix Barney style.